If we graphed y equals x squared plus 1, there's no compression or stretch. It's not moved right or left. It would just be up 1. So it would be our parent function up 1. So vertex would be at 0, 1. From there, it would be right 1 up 1, right 2 up 4, left 1 up 1, left 2 up 4. Okay. When we're solving quadratics, when we're looking for solutions, what are we looking for?
Start. The zeros.
Good. The zeros. The zeros. What are the zeros?
There are no zeros.
That's true on this one. I mean, in general, the x-intercepts. Good. Right. The zeros are the x-intercepts. Like Kylie just said, there aren't any here. Right. Okay. Well, so if we took this same quadratic function and we solved for x squared plus 1 equals 0, and we subtracted 1, and we had x squared equals negative 1, we've always said, well, we can't take the square root there, right? Can we take the square root of a negative? No. Well, now we can, okay? Square root of negative 1 is I. Okay, complex numbers, imaginary numbers. You'll hear both terms, imaginary numbers, complex numbers. Okay, but from here on out, square root of negative 1 equals I. Okay. There's no real solution since no real number times itself can equal negative 1. Mathematicians overcame this problem by creating a new system of numbers using an imaginary unit I, which is defined as I squared equals negative 1 or I equals square root of negative 1. So I squared is negative 1 because the square root of negative 1 times the square root of negative 1 equals negative 1. Square root of negative 1 multiplied by itself would equal negative 1. Same concept as if we did square root of 2 times the square root of 2. Well, that would equal 2, right? Okay. So if you look at I cubed, that's square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, we already said square root of negative 1 times the square root of negative 1 equals negative 1. And then we have a third square root of negative 1. So you will see this answer written as negative square root of negative 1 or negative I. Same thing. Both are acceptable. You'll see it both ways. Okay? I cubed can be written as negative square root of negative 1 or negative I. Same thing. Now, I to the fourth is square root of negative 1 times the square root of negative 1 times the square root of negative 1 times the square root of negative 1. Well, that would give you negative 1 times negative 1, which would give you positive 1. Okay. So, the i's work in a pattern of 4. If you did I to the fifth, square root of negative 1 multiplied by itself 5 times, that would give you I. I to the sixth would give you negative 1. I to the seventh would give you negative I. I to the eighth would give you 1. And then the pattern would start over again. I to the ninth would give you I. I to the 10th, negative 1. I to the 11th, negative I. I to the 12th, 1. Keeps working in that pattern of 4, which allows you to simplify if you need to, okay? So for example, I to the 7th, we're working in patterns of 4, so we'll divide the exponent by 4. How many times does 4 grow into 7? 1 time. What's my remainder? 3. So I to the 7th simplified would be I cubed or negative I. Okay. That remainder will tell you what it simplifies to. Okay. I to the 5th, we divide by 4. How many times does 4 go into 5?
1.
What's my remainder?
1.
1.
So it's I.
Yep, it would simplify to I. I to the 28th. How many times does 4 go into 28? 7. What's our remainder? 0. So it would be 1. Good. All right. We cannot get a remainder of 4. Why can we not get a remainder of 4? Because we're dividing by 4. Right. Exactly. Right. So we're dividing by 4 so we can get a remainder of 1, I. We can get a remainder of 2, I squared, negative 1. We can get a remainder of 3, negative I. Or it'll divide evenly, which would be I to the 4th, or 1. Okay? 4. How many times does 4 go into 35?
8 times.
8 times. Remainder of?
3.
3. So I to the 35th power would simplify to I cubed, which is negative I. Okay? Try and do 5, 6, and 7. Try and do 5, 6, and 7. This is what you should have got. Any questions here? Okay. All right. Solving quadratic equation using square roots. Is that what it says?
Yes.
All right. So x squared equals 16. Pretty easy. What's the square root of 16?
4. Positive, negative 4.
Plus or minus 4, right? Because 4 squared equals
16.
negative 4 squared equals slash. If we graph that, where would that cross the x-axis at?
4, negative 4.
4, negative 4. Good. All right. B, x squared equals 12. So remember, when we simplify radicals, that's not a perfect square, right? When we simplify radicals, right. As Royce just said, 2 squareds. Wait, what'd you say, Royce?
2 square roots of 3.
We need 2 of a kind to be able to take 1 out. I thought you said something else. All right, so a couple ways you can look at it. All right, you could factor it all the way down to its most simple factors, 2 2s and a 3, 2 of a kind to take 1 out. Okay. Also, like at 4 and 3, you know 4 is a perfect square. You can take out a 2 from there as well. Okay. I always take out the number of the perfect squares as I do that. Okay. And that should be plus or minus 2 squared of 3. So silly of me. Okay. Right. So if you graphed that, that would cross the x-axis at like 2.1 something. Okay. All right. E. Now we're introducing our i's. Okay. Square root of negative 9. You can make that 9 and negative 1. What's the square root of 9?
3.
Good. What's the square root of negative 1? I.
So it'd be 9 times, or 3 times I.
Yep. It'll be 3i. Good. 3i. So what I do whenever I'm taking the square root of a negative, I just take that I out at the beginning. Okay? I just take that I out at the beginning. Less eye candy to distract you. Okay? F. All right, now, this isn't plus or minus. Why is this not plus or minus? Right, is it going to cross the x-axis twice? No, it's never even crossing the x-axis, right? All right, F. Square root of negative 5, what do you think that would be?
2.
Does 5 simplify?
No.
No, so just be I times the square root of 5. Now that order does not matter, right? It's multiplication. Just make sure, if you put the I second, make sure I can clearly tell you did not put that I inside of the radical. Okay? So maybe use parentheses or something to separate it. Okay. All right, C, 30. Not a perfect square. Need to simplify. Okay. So what are two factors of 30 here?
Not 5.
5 and 6. 3 and 2. We have any pairs of 2?
No.
No. So that answer would just be,
8 squared root of 30.
yeah,
Plus or minus.
square root of 30.
Okay, boys.
Someone do that in the calculator. What's the square root of 30? Is it
Something a little bit less than
5.4? Yeah. So that it would, so right, if you graph that, it would be crossing the x-axis at 5.4 and negative 5.4. All right. D. Simplify that there. What are two factors of 48?
16 and 3.
That's a good one. I do like, why is 16 and 3 a good one?
Because 16 is a perfect square.
16 is a perfect square. Take out a 4. That poor little 3 is stuck inside the radical. Had to say goodbye to the 4s. All right, G. Again, easiest thing to do here, just take out that I. Less eye candy. So we have I times the square root of 72. Now we're just going to simplify the square root of 72. Two factors of 72.
24 and 3.
What?
24 and 3.
Show off.
All right, we can do that.
You can do
I would rather not, but I'll do it just for you, Royce. All right, 24 and 3. All right. So, 3,
9 is a perfect
3 and 1, no more. 24. What are two factors of 24?
Royce just had to be
Roll.
Royce
Really
had to be
had to be
extra.
special.
He had to be extra.
6 and 4. So we're just going to take this all the way down to 3 and 2, 2 and 2, and 3. So, how many pairs of 2 do we have?
1, 2. No, there's 3 and 3 and 2.
We got 3. We got 2. So that'll give us
I times
3 times 2 times I. And what's left inside the radical?
2.
That 2.
That'd be 6I.
6I
Thank you, Royce.
times the square root of 2.
You're welcome.
Amazing.
All right, do H. Do H. All right, I'm going to take out that I. Now, I know Royce would use 6 and 3, but I'm going to use 9 and 2 because 9 is a
perfect square.
perfect square. 3I times the square root of 2. Okay. Next part here, adding and subtracting. So adding and subtracting, we treat the i's just like we would a variable, okay? They're same variable, same exponent, or yeah, same variable with the same exponent. You can add and subtract them. So here that would just be negative 4 plus 6i minus 2 minus 9i. So we can do negative 4 times negative 2, which gives me negative 6. And then 6i minus 9i, give me negative 3i. Second example here, common mistake people make. They do 3 minus 2i, then they subtract a negative 4 and they don't subtract the I. So just to make it nice and easy, distribute that negative to give you plus 4 and minus I, and that will help prevent you from making that common mistake. Okay? People will good about subtracting the negative 4, but then they forget they got to subtract the I too, right? All right, so that'll give us 3 plus 4, which is 7, minus 3i. Next part here, I think this was a little typo, so just erase the negative 2 point part. We'll do 5i times 8 minus 9i, okay? Again, none of this, or for the most part, none of this is very different. We would distribute the 5i, okay? 5 times 8 is?
40.
Good, so we get 40i. 5 times negative 9 is?
45.
Negative 45. What do you think I times I is?
I squared.
I squared. What did we say I squared was earlier? Good, Royce. What's I squared?
-1.
Negative 1. So this is going to be 40i minus 45 times negative 1. So it's 40i plus 45. Next example. We have a binomial times a binomial. What do we do when we have a binomial times a binomial?
FOIL.
We FOIL. First, 9. Outer, 6i. Inner, negative 6i. Last,
Negative 4i.
good. So, in the middle, the 6i's cancel. And that'll give us 9 minus 4 times negative 1. Because I squared is negative 1. Which that would give us 9 plus 4. Gives us 13. Here. Monomial times a binomial. All right, we need to distribute. What's 2/5 times 10?
4.
Good. So I'll give us 4i minus. What's 2/5 times 5 halves?
1.
1. So that'll be minus 1 times I squared. All right. So I squared is
Negative 1.
negative 1. So that'll be minus a negative 1. Which will give us plus 1 there. All right, try and do the next 3. All right. So, stop talking. Monomial times a monomial. That would give us 33i squared, which would give us negative 33. Here we need to distribute. That'd give us 15i minus 12i squared, that would make that 15i plus 12. And then here we need to FOIL. First, 25, outer, 10i, inner, minus 10i, last, minus 4i squared. So that would cancel. 25 plus 4 give us 29.